next is lag compensator. Okay, so we know that lag compensator with bode pump. Okay, so what we are going to do, we are going to compensate using the lag compensator. Okay, the question will be like this. That is, a unity feedback system has a open loop transfer function. G of s is given as a divided by s into 1 plus 2s, and this we have to design what, a lag compensator for that phase margin. How it is given? Phase margin is given as 40 degree. Okay, and so that steady state error as what input it is given? It is given as ramp input. Steady state error at ramp input should be less than or equal to how much? 0.2. Also, solution. First, what we have to do, we have to finish the first step. Before that,
Find the value.
so first step we have to find the common three steps for all three common compensators. Lag, compensator. For all three compensators, first three steps are common. The first step is what? To determine or find the value of K for what? For the steady state requirement. Okay, for steady state requirement. What is given that steady state requirement? DSS is given as ramp input. So you know the tabular column. For ramp input, what is the steady state error constant? For ramp input, what is the error constant? That is 1 by K suffix B. And here what is the error given? The error is given as steady state error is given as for ramp input What is a constant number? You have to take that constant number outside. You have to make it in the form of 1 plus st. After that only you should solve it. Okay. So now it is clear that g of j omega is 5 divided by j omega into 1 plus j omega. First, what you have to plot? You have to plot the magnitude plot. To find out magnitude plot, what you have to look after? You have to look after the, what is the first step to find out the magnitude plot? You have to look after the corner frequency. First step, you have to look after the corner frequency. What is the corner frequency? The one and only term which is over here. What it is? 1 plus st. So what is the coefficient of s here? 2. So what is the corner frequency? 2 radian per second. So we have to assume, next what you have to do? You have to assume the lower frequency and higher frequency. Lower frequency should be less than the corner frequency. Higher frequency should be greater than the corner frequency. Since our corner frequency 2, we can assume the lower frequency as assume it is 0.1 radian per second. And assume our higher frequency greater than 2, we can assume it as, for calculation it will be easy. So we are assuming it as 0.110. Because in the similar graph sheet, the x-axis it is already marked, the omega value was 0.110. It will be that scaling only. Okay. So now omega n, omega h over. Next what we have to do? We have to make the Taylor column for term. Next what? Corner frequency in radian. You have to write all these things. Okay. In radian per second. Next what? Next what you have to write? Slope. Next change in slope. Do it along with me. Okay. So next is change in slope. So what is it? The first term. First term from g of j omega 5 by j omega. So the first term is 5 j omega. What is the corner frequency here? Here there is no corner frequency. Only with the term 1 by 1 plus 2 j omega only there is a corner frequency, that is a coefficient for x is there. S is there. Okay. The corner frequency will available only in the term what? 1 plus st. If it is 1 plus st in the form, there only the corner frequency is. That only you know in the coding code itself. So here corner frequency nil. So what is the slope here? Denominator there is a j omega. So slope will be minus infinity. Is there any change in slope? No. Next term what it is? 1 divided by 1 plus 2j omega. Okay. So here what is the corner frequency? Here the corner frequency is 2. Okay. And what is the slope here? Denominator there is here j omega, so it will become minus 20. What is the change in slope? Minus 20 minus 20 will become minus 40. Clear up to this? Next what we have to do? We have to find gain for all omega values. So first a at when omega is equal to omega l till the value change in the slope comes. What is the formula for gain? Formula a is equal to 20 log of magnitude 5 divided by j omega. Okay. I am using omega as omega l. What is omega l we have taken? We can take it as 0.1. So what will become a? It will become as 20 into log of 5 by omega. That is 20 into log of 5 by 0.1. What is the answer for it? Answer for a by it is 33.9. We can take it as 33.9. Approximately take it as 34. No, dV is magnitude. A. Okay. So next, the same way you have to find a for when omega is equal to omega c. You have to find for all these three: omega l, omega c, omega h. Okay. What is the formula here? The same. 20 log log of 5 divided by 2. What it is? 7.9. So approximately take it as 8 dB. Okay. So do it. Let's make it. One thing we made it wrongly. Okay. So here the coefficient of j omega is in the denominator. So we should do like this: 1 divided by 2. 1 divided by 2 j omega. First look at the numerator. Numerator, that is a constant. So now you need to worry about the angle. So the denominator, what is there? 2j omega is there. For a first single j omega, we will mark it as, since it is in the numerator, sorry, since it is in the denominator, we will mark it as minus 90 degree. So the next term is 1 plus, that is a plus b. Okay, a plus b theta is in the form. So we will take this tan theta is equal to b by a. So if we take it like this, we will be making it as, since in the denominator it is minus tan inverse of, what is there? b by a means here it is 2 by 1. What is b? Omega. Okay, b is what? 2 into omega. Clear? So it will become minus 90 degree minus tan inverse of 2 omega. Clear? Next, what you have to do? Then you have to make the graph. You have to assume the various value of omega. Clear? So for various values, already the low omega is 0.1. The next corner frequency is 0.5. So you can, the highest frequency we have taken it as 10. The remaining values you just assume it will be as 1, 2, or you can assume it as 2, 5. Since we have to get the phase plot. Okay. So for 5, now substitute the value for omega over here is 0.1 and then we need 5 value. Minus 90 minus tan inverse of 2 into 0.1. What it is? Minus 90 minus tan inverse of
minus 101.
minus
101.
101. Is it 1 not? Okay, right. Next, when it is 0.5
Minus 135.
minus 135. When it is 1 when it is 1, when it is 2, or when it is 5,
Or 1 minus 153.
minus 153. And if for 20 degree, or for 2,
Minus 165.
minus 1,
65.9.
65.9, right? So we can state it as 166. Okay, the next 10.
Minus 177.
77. Okay, minus 177. Now we can able to mark this plotted as phase plotted border. Second step over. Okay, next what you have to do? We have to go to the third step, which is common for all the compensator. What is the third step for?
Find the phase margin of
Find the phase margin for the uncompensated system. So let us find phase margin for uncompensated. What is the formula for finding the phase margin? Phase margin, gamma is equal to
180 degree plus 5
180
GC.
degree
5 GC. Plus 5
plus 5
GC.
GC. How will we mapping the 5 GC?
5 GC is equal to
This is your border plot, right? Marking a straight line from 0, which cuts in the magnitude plot. For this phase angle, you have drawn the phase plot, something like this. What do you have to do? If it is like this, okay? Something like this. Okay, next step. From the 0, you have to make value should cut it at magnitude plot. Next, you will be cutting over the phase plot. This point is straight phase margin which is given in the question is 40 degree, but the uncompensated systems phase margin is what? 18 degree. Therefore what we have to do? Therefore we have to compensate. Therefore the compensated who is used? Lag compensation is used to the system. Clear? This thing you have to make it clear. Next, what you have to do? You have to go to the step 4. Since it is lag compensation, what is our step 4 for lag compensation? We will be finding out the new phase margin. That is gamma n. What is the formula?
Gamma D plus epsilon.
Gamma d plus epsilon. What is epsilon?
Fine.
That is this way. What is epsilon? It is a, you have to write it down for each step. It is the adjustment angle. You should not write it directly as 5 degree. This adjustment angle that is 5 degree. What is the design? What is gamma suffix d called?
18.
It is called desired phase margin. So that is desired phase margin given as 40 degree. Then what is our new phase margin will be? Gamma n is equal to 40 degree plus the adjustment angle 5 degree which is equal to 45 degree. Clear? What is the next step? Step 5.
Determine parameter for
Determine the parameters for lag radian per second. Okay, from the border plot omega GCM will be 0.5 radian per second. Okay, the same way from the plot AGCM will be 20 dB. Okay. What is our from the plot? Omega GCM will be 0.5. You know how to get it. From the 5 GCM we have get it. 5 GCM there is a formula. What it is? Gamma n minus 180 degree. Gamma n already we have got it. Gamma n formula is that is phase margin. The same phase margin plus epsilon. Okay. So that we have substituted over there. From the 5 GCM we have looked after the Bode plot. We have got omega GCM. By that we have got AGCM also. So that is from the Bode plot. Clear? Now we have to get the parameter beta. The formula is 10 to the power AGCM. That is 820 divided by in the formula that is a 20. It will become 10 to the power 1. That is 10. So what is the value for beta then? 10. Then what is the parameter we have to find out? T. Look at the lag compensator. The formula for find out the T.
10 by
10 by omega GCM.
10 by
Omega GCM.
omega GCM. What is the omega GCM?
0.5.
0.5. So 10 by 0.5 will become T is
20.
20. Okay, now parameters are over. Next one is the step 6. Step 6 is transfer function for
Lag compensator.
what is the system now? Compensator system. What is here? Compensator system then it will become GC of S. What is the form of lag compensator?
Plus
Plus 1 by T.
100 by plus
1 by
beta T.
beta equal to T. So that is equal to S plus 1 by T is
20.
20 divided by
Plus 1 by
20 into 10. Okay, shall we make cross multiply? It will become 20 S plus 1 by 20. The whole divided by 200 S plus 20 into 10 it will become 200. Should I write it inversely? So it will become 200 divided by 200 into S plus 1. So shall I cancel it? So if you cancel it, it will become 10. So what will your transfer function will be like? 10 into, that's a 10, right? Have you copied this? Have you noted down this? So, what's our transfer function will be like? There is a number over here. After cancelling, there is a number over here. First you have to write it down. 10 into, you should write this form as 1 plus S. That is 1 plus 20 into S. The denominator it will be 1 plus 200 into S. Clear up to this? Next what you have to do? You have to draw the product for the lag compensator system. For the next first system what you have to do? Replace
Yes, with 0.
that is 0. J omega will be equal to 10 into. Before doing that, what you have to do? Just before doing that, you have to draw the block diagram, right? GC of S, G of S, your C of S output. Since it is unity feedback system, unity feedback to the comparator is 1. What will be here? 1 by beta G naught of S will be equal to, if we product is all three are cascaded in series. So what is G naught of S then? 5 into 1 plus 20s divided by S into 1 plus 2s into 1 plus 200s. So this 10 and 10 will get cancelled. If I multiply